We have reached the last Mr. Lovelady lecture. So before we get going on this, just go ahead and set your pencil paper down. Stand up from your seat, couch, bed, wherever you're watching this, and just do a little dance. I'll give you 5 seconds to just get a dance out. I'm dancing right now. Do I need to have music playing? Are you not going to do it? What's going on? All right. Oh, okay. Well, if you're not going to do it, we'll just go ahead and go straight into the lecture. All right. I told you at the end of the last one we're going to be doing volumes again, and this time I'm going to give you a different method. It's called volumes by cylindrical shells. Well, why do we need to do volumes by cylindrical shells? Why can't we just use the discs and the washers that we've grown accustomed to? Well, if I'm given a problem like this, doing discs, I guess this one would come out to be a shell whenever I would rotate this one around, not a shell, a washer. Whenever I'd rotate this one around, it would be really tough. It'd be really hard to get my hands on this left end point and the right end point, and it's going to be a lot tougher. And so we have this different method in which we get to use cylindrical shells. So here's the idea of what I'm drawing with this cylindrical shell. And I'm sorry, we're in the, I don't know if we're in the beginning, middle, or maybe hopefully towards the end of all this coronavirus, but all I can see when I look at this is toilet paper and the lack thereof in all of our big box stores. And so if you hear me refer to as a toilet paper today, that's going to be why, all right? And so I'm wanting to find the volume of just this shell. I don't want the volume of all this stuff, of all the air that's in the middle. It's kind of like the donut that we had, the washer, but it keeps going down in this to form a full shell on this. And so the best way I can describe doing this, finding this volume, is going to be taking the volume of the outside roll of the toilet paper all the way around the outside and the shell that goes down. And then subtract off the inside, the core part of the toilet paper that everybody throws away right there, right? So anyway, if I could just get the difference between the black part and the blue part right here, I would get the meat of how much toilet paper I would have left. Okay. So let's see how to get that. As you can see, I've got some different stuff labeled on here, and I'm gonna derive the whole formula going down. Okay, so we're talking about a shell right here. So the outside shell, as you can see, I use the radius to be R2. And so it's a circle up there on top. So it's just going to be pi R2 squared, and then it goes down h times. So I still got the pi r squared h that I had with a right circular cylinder. And so I'm going to subtract off from that, well, V1, okay, that's my inside part, the core of my toilet paper right here. And so it's got a radius of 1 right there. So using the same formula, has the same height, it's still pi because we're dealing with a circle. That would be how I would find that volume. Now I've got some repetition in here. I see that I have pi in common in both of these terms. And I have an h in common. So just for fun, I'm going to pull the pi off the left side of the equation, and I'm going to pull the h off the right side of the equation. So what that leaves me with is something that factors on the inside. It's just difference of 2 squares, isn't it? Hope so. I've been teaching it like that for a while. Now, this next step might blow your mind a little bit, but I'm going to multiply everything by 2 over 2. I'm going to multiply by 1, so I ensure I do not change the value of my equation right here. So I'm going to put a 2 out here in front, and I am going to, this R2 plus R1 over 2, I'm going to put that bottom 2 right there. Okay. I'm going to move the h around a little bit. My property of my commutative property says that it doesn't matter what order I multiply things in, I should get the same answer. So I got 2 pi. I'm wanting to rewrite this guy. Look what I'm left with on this. I've got R1 plus R2 divided by 2. Well, that is exactly how I average uh, my r's. If I was to average my radii, I have this one that goes to the inside, this one that goes to the outside. If I was to average them, I would land right in the middle. I'd get a radius that comes right through here, which I have denoted with an R. So I'm going to rewrite this as an R right there. And I got my H. Well, I also want to rewrite him. Is it okay if I just call that delta R, the change in R? That tells me how thick my radius is. If I take R2 minus R1, it gives me this distance, which I've denoted with the delta R. So good. And so that's the equation I want to use. Let's go over it. I've got the circumference of a circle. Okay. I've got the height of my toilet paper. And I'm going to multiply it by the thickness of my toilet paper. How many rolls, how many rounds do I have left if I'm spinning it like a contestant on The Price is Right? Okay. So keep this in mind. I'm going to box this in. That's my volume that I have so far that I've come up with. And I'm going to try not to erase it. If I erase all the rest of this. Oh no. Oh my goodness. What did I do? Hold on a second. All right, not a big deal. All right, I was able to salvage most of it. Okay, so tried to erase with my pointer on my smart board. Never a good idea. So I'm wanting to take this function in the area that comes underneath it right here, and I'm going to rotate it about the y-axis. Okay, so we've done this before, and it looks something like this. Oh boy. Yeah. Okay. And what we did with this was we put little washers going around. Well, I'm not doing washers anymore. Here's going to be the difference today. Instead of doing those washers like that, what I'm going to do is I'm going to find an approximating strip on each one, and I'm going to put in these rolls of toilet paper. Okay? And so I get these cylinders on there. And the thing is, there's tons of cylinders. I could have easily drawn it here. If I would have rotated that approximating strip going around, I would have got a much taller cylinder. And if I keep adding up the volume of all of these cylinders, it should eventually tell me what the entire shape is going to look like. Okay? So the idea is to make all these little approximating strips, delta R, as small as possible. So I think I can rewrite my volume now to be volume is equal to, let's see, we had the 2 pi r right here. Okay, so 2 pi r, I'm just coming over x units right here. So instead of 2 pi r, my r is going to become an x. So I have 2 pi x. Okay. Now, I had the height. The height of my toilet paper, again, it's going to vary. Okay, so like the height of this green one right here, that's the height. Well, it's also going to be my function value. So instead of height, I'm going to have my function value. And the idea is that this delta r is going to be so small, and we're not dealing with r anymore, so my delta x is going to be so small that I can just call it dx. And what I'm wanting to do is evaluate that from the same a and b that I had in the last time. Okay? So I still have my circumference right there. I still have my height right here, and I still have my thickness right there. That was pretty cool. I didn't even imagine it moving like that, but it did. And that's what this slide's talking about. Oh, erase. And that's what this slide's talking about. So all of this, if I'm finding the volume of a solid, then I'm rotating about the y-axis. The region under the curve from A to B is going to be able to be found using this formula right here. Okay. Now, again, you're going to see me a lot pull this 2 pi out in front because it is just a constant. So all I've got to remember on this is x times f of x. It turns out to be a lot easier on some problems. You don't have to worry about disk or washer. Everything's going to be a cylinder. Okay? So let's go back to that original problem that I put on the first slide, the one that we said was going to be really hard to use disks and washers on. Okay? And so I'm going to redraw it. I'm going to just do a rough sketch of it so you can kind of see what's going on with it. And so I had this thing that went something like this from 0 until 2. So now what I'm going to do is I'm wanting to rotate it around the y-axis, it says. And so now this little hill, I'm not going to redraw everything. Instead, what I'm going to do is I'm going to find an approximating strip on it. I'm just going to do one of them. And so if I was to rotate this approximating strip around the curve, I get this roll of toilet paper, this circular cylinder, circular shell, I should say. So the height of my toilet paper right here is just going to be my function value, this 2x squared minus x cubed. Okay? And then the circumference of my circle, well, I'm still just coming out x units, right? So the circumference of my circle is going to be 2 pi r, or in this case, 2 pi x. So my volume is going to be 2 pi x times my height times my thickness. And then all of my approximating strips, this is what throws people off, all of my approximating strips are going from 0 until 2 right here. And I can easily find that. You might be saying, well, where did that 2 come from again? Well, I can find that 2 if I just look and see where 2x squared minus x cubed intercepts this line y equals 0. So if I pull out an x squared, I get x squared equals 0. So x equals 0. That's one of my endpoints. And then if I get 2 minus x equals 0, x equals 2, that's my other endpoint. So all my approximating strips will be going from 0 to 2 that I am rotating around. Now, like I said, this is probably going to be the only time I didn't do it. I'm going to pull this 2 pi out in front. It just is in the way. And so that's going to allow me to distribute this x through as well, which is going to make my integration step much easier. All right, so let's raise the exponent by 1. That's going to be a 4 over the new exponent. That's going to be 1/2 x to the 4th. Raise the exponent by 1. Put it over the new exponent, 1/5 x to the 5th. And we are going from, oops, I don't have a dx. And we are going from 0 to 2. So if I plug in 2 in for everything, it's going to be 2 to the 4th, 16. Divided by 2 is 8. And then 32 over 5. Right? Common denominators, that would be what, 40 over 5 times, so that would be 40 over 5. Difference of that's 8. 8 times 2 is 16 pi over 5. So your answers look very similar to what they did in the last section, but we have somewhat of a different method as far as getting there. Okay. I don't have just a whole bunch more of these, but I want to go ahead and show you some different ways that you might see this, because we're not going to look out. Sometimes our toilet paper is going to be oriented the other way. We used these two curves a lot in the last slide. I don't remember which way we rotated them in every way, but in the last video we used these a lot. So I'm going to try to condense down to one shape on this. Okay, this time we're rotating about the y-axis, so it's going to be very similar. I might let you guys do this one. So I have this region, and I am rotating it about the y-axis, it says. So that means that its reflection would be over here. And I get an approximating strip like so. Height's going to be a little bit different on this one, isn't it? Because look, it doesn't come all the way down to the axis. My roll of toilet paper or my cylindrical shell is actually sitting up in some spots. If I was to draw it all the way in right here, yeah, it would be down, but it's not. Okay, so my shell height on this one, the shell height, well, I did a function, is going to just be the top line right here, this x, minus the bottom line, which is x squared. It's just a difference in my two functions. That has to tell me how tall the function is. It doesn't come all the way down to the x-axis. So I'm ready. I think I'm ready to rock and roll with the integral here. I'm going to pull my 2 pi out in front. So I still have 2 pi, and then I came over x units. So that's still my circumference is 2 pi x. Multiply it by the height of the shell. In this case, it's going to be the difference between the two functions, top minus bottom, times the thickness. Always going to spend a step distributing that through. Maybe once you get better at it, you'll be able to do that in one step. I'm evaluating that from 0 to 1. So I'm wanting to do 2 pi 1/3 minus 1/4. Well, 1/3 minus 1/4 is 1/12. Multiplied by 2 would be 1/6 times pi. So my answer is pi over 6. I like shells better. If it's one that I can set up a good shell on and make sense of, I always use shells on it instead of the discs or washers. Now, we did this one, I believe, when I introduced the disk. We did this exact problem in the last video. Okay, I'm going to rotate it about the x-axis this time, and I've got the region under the curve swoop, right? And so this is where I introduced it, and we had the whole bowl working, right? And we had a disk right there. And was able to find the cross-sectional area of the disk, add it to all the other disks that are in that bowl, and we found the volume. Okay, let's see what it looks like with a shell this time. Because if I'm just going from 0 to 1, I'm rotating about the x-axis, that means that my shells have to run this way. My toilet paper is actually like on the roll this time, if you want to think of it that way. I brought that the wrong way. There we go. So if I'm rotating it the other way, that means that my height this time is going to be, I'm sorry, my radius this time is going to be y. And then the height of my shell is running this way. All right, so I've got a little bit of work to do. The shell height is going to be, again, there's formulas for this, but I know that this distance right here is 1. And so if I subtract off this small distance that I did not go back, well, that distance right there is an x distance that corresponds to this x right here. So that distance has to be y squared, making it so that my height is going to be this 1 minus the x squared. I'm sorry, the y squared. I said y. That should be all I need, okay? So my volume, so I am stacking all these approximating strips. I'm starting down here at 0, and then I go all the way up here to this little bitty one that's up here at 1. So my approximating strips are still going from 0 to 1. I'll pull my 2 pi out in front. The radius of my toilet paper roll, of my shell, is going to be y right there. That means that my whole problem now has to be in terms of y, which is why I switched it around and made it so that my height is in terms of y as well. I'm going to spend my step distributing my y through, and then I'm going to integrate. 1/2 y squared minus 1/4 y to the 4th, evaluated from 0 to 1. So if I plug in 1, I get 1/2 minus 1/4. 1/2 minus 1/4 is 1/4 times 2 is 1/2. So I get half a pi. This is a rare case where I would say that doing the disk was a lot easier. Me just doing the pi r squared and leaving stuff in terms of x was easier, but we're gonna have to know both ways, okay? One last one. We've done everything about the x-axis and y-axis. You know that it's coming. Let's do something about the random line. I'm gonna choose x equals 2. Again, you're going to see me draw this and have it try to make sense to you. Okay. And so, again, I'm going to try to get this in one drawing. I usually can't get it, but I'm kind of thinking ahead a little bit. Again, if I was to set this equal to 0, it's going to tell me what I'm evaluating from. So if I factor out an x, I get x equals 0 and x equals 1. So more importantly, I have a parabola that's facing down that goes from 0 to 1. Okay? I am wanting to rotate that about the line 2. And so that's going to have me, whenever I rotate that, it's going to have me having a parabola sitting on 3 and 4 over here. I don't really need the 3 and 4. More importantly, what I need is my approximating strip. Okay, I'm going to get this huge cylinder going this time. And I'm wanting to find the volume of it. If I was to have infinitely many little cylinders in here, I want to add up the volume of all of them, and hopefully it'll tell me the volume of this shape, of this solid. Okay. So we got a little bit of work to do. My volume is equal to, again, I'm going to pull my 2 pi out in front. That's just how I work. And I'm not, a lot of people are going to say, well, I got to go from 0 to 4. No. It's just my approximating strips right here. My approximating strips are going from 0 to 1 still. Okay, so that's not going to change. What is going to change is the radius. Let's look at this radius right here. My radius runs from here all the way back. Or maybe it'd be easier to go, maybe it'd be easier to go from here in. Because I know that this distance right here is 2. But once again, I shorted myself. I shorted myself x units. Okay, and I get to use that x this time. And so the radius of my big first shell that I drew right here is going to be 2 units minus the x that I shorted that first approximating strip. So a little bit of change right there. I can't just do 2 pi x or 2 pi y this time because I'm not on the axis. Next, I got to do the height of each strip. Well, luckily it's sitting on the axis, so this is always staying the same. The height of each strip is going to be whatever this blue parabola line is, which we said was x minus x squared. Got my cleanup. A little foiling action happening here. Oh man. So let's see, let's do it. 2x minus 2x squared minus another x squared. That'll give me minus 3x squared. And then I have negative and negative, like a positive, and x cubed. I integrate. Raise the exponent by 1, put it over the new exponent. That's just going to be a nice little x squared. Raise the exponent by 1, put it over the new exponent. Awesome. Loving this so far. Oh, there's a fraction. It came in and wanted to play right there at the end. But, again, 0 is going to wipe out everything. If I plug in 1, I'm going to get 2 pi times 1 minus 1 plus 1/4. That's just going to be 2 pi times 1/4. Again, I got my answer, 3 pi over 2. Okay. Not nearly as long as the last video, thank goodness, because we're just kind of mainstreamed on this one idea of shells. And I'm telling you, the best thing I do to help me figure out some of the tougher ones is have a drawing. My drawings aren't very good. Hopefully you guys are a little bit more artistic than I am. You can make sense more of the drawings, but you got to get those toilet paper rolls. You got to get those cylindrical shells drawn in there so you can see what they're stacking from, what the radius could be. And again, you can definitely YouTube a video to find an easier way to find the radius. It's more formula driven. It just makes more sense to me if I draw it out and figure out if it's plus or minus and where that strip length is. Okay. Here is the last homework assignment. So have questions during the Q&A ready for me, and we'll tackle. Have a good day.